Okay, continuing on with our fossil fuel discussion, we're now going to move on to oil. And you also hear the word petroleum or oil. So as you see there on this slide, petroleum, if you break down the word, petro means rock, oleum means oil. So it's oil from rocks. You're basically drilling down into the earth to find these pockets of oil that's captured up in these rock areas, and we are pumping it up to the surface. Now, there's different types of oil wells, but basically what you're doing is you're drilling way down, and this oil is found in these pockets, and it's actually under quite a bit of pressure. So when you hit that, you get, in the movies, we struck oil and it's spurting out of the ground. It's under a lot of pressure. So as soon as you tap into that pressurized pocket, the oil wants to shoot up to the surface and it's really easy to get it initially. But after that initial pressure is out, there's still quite a bit of oil in the ground. And so then what we have to do is we have to use water, heat water to create steam and send that steam down there, inject the steam into the well, and that helps us excavate more oil. You can never get all the oil out. It just requires way too much energy and too much time. So usually it's about, you end up extracting about half of what's really in there. So, they'll say like there's, I don't know, 300,000 barrels of oil held in this reserve, but really in the end, you're probably only going to get about 150,000 barrels of oil out of that. Now, we also have a lot of mining for oil offshore because a lot of our oil is found below oceans because as you learned hopefully in the video that you watched where that gentleman was discussing how fossil fuels form, a lot of it comes from more of your slimy guys, okay? So your algae, your zooplankton, the marine organisms, and they get squeezed under the ocean, cooked from below, and that forms your oil. Now, the oil that comes out of the ground is known as crude oil, and what that means is it's a whole big mixture of all these different lengths of hydrocarbons. And hydrocarbons here, as you see in my little model, this is a hydrocarbon chain. These black atoms here are your carbons. They have those four bonding sites. And remember, carbons are very social. They want to grab on. So they grab onto each other, and then the white here, these are my hydrogens, hence hydrocarbons, okay? And they come in all different lengths. So, and by the way, my white are hydrogens, but I ran out of white, so I have some green ones that also are representing hydrogen today. They come in all different lengths. You can have shorter chains, you can have longer chains. It's this whole crude oil is this whole big mixture of all these different lengths. You have really, really, really long ones, short ones. And so what they do is they take this crude oil out of the ground and they have to refine it. And when you're refining it, basically what you're doing is you're cooking it and you're cooking it and heating it to a point where the hydrocarbons start to evaporate off at different temperatures. So, say you get to like 200 degrees and the hydrocarbons for the length that you use in gasoline, they evaporate. And so we collect and siphon those off and condense them back down, and you get gasoline. And then you heat it up a little more and you have the hydrocarbons that are bigger and those come off for jet fuel. So you're basically separating out all these different lengths of hydrocarbons, and each different hydrocarbon has a different property. They all can be used to do different things. Now, to give you an idea, you'll hear in the news like barrels of oil, or a barrel of oil nowadays is $99 or whatever. Well, how much is a barrel of oil? A lot of people wonder. One barrel of oil equals about 42 gallons of oil. So, to give you an idea there. Now, if you take a barrel of crude oil and you refine it down, what you end up getting is about 19 and a half gallons of gasoline, so almost half of that is gasoline. You get all about just over 9 gallons of distillate fuel. And what that is basically your diesel, your heavier stuff that you use in your trucks. This is also the oil that you put in your homes to run your oil burning furnaces to heat the houses. You only end up with about 4 gallons of jet fuel. Okay, so out of 42 gallons, only 4 gallons of it is jet fuel. And this is why your airplane tickets cost so much, and why when you take a carbon footprint quiz or an eco footprint quiz online and it asks you, wants to know how often you're flying, and you're wondering, why is it asking me how often I fly? This is why. This severely impacts your carbon footprint. The more times you fly, that major number of barrels of oil that you have to go through in order to get from point A to point B on a plane. So this is kind of what it looks like. Over here on the left-hand side, you'll see that they take the crude oil, they put it into a furnace, and the furnace heats it up, and then all the different substances evaporate off at different times, and then they collect them and they condense them back down, and you get the different sources. You got fuel oils, diesel oils, kerosene, gasoline. Um, at the really warm temperatures, that's where you get like the paraffin wax, asphalt, all that kind of stuff. So, all different things. And the picture on the right-hand side there is basically one barrel of oil broken into all the different parts that you get. So you can see that the red chunk there, a large part of that is your gasoline. Again, 19.5 gallons out of about 42 gallons. This says about 44 gallons. So somewhere in that range. The distillate fuel or your diesel fuel, about 9.2 gallons. The jet fuel is that lighter blue. And then you have all the little teeny tiny pieces that make up all the rest of that barrel of oil. Now, if you look around your house, you'd be surprised to know how many products come from oil. Okay, if you're using any plastics at all, which almost all of us have plastic around, that is a petroleum product. Plastic grocery bags, plastic notebooks, plastic bookshelves, anything in your house that is plastic, that's a petroleum product. A lot of your vinyls and other, your shower curtain, your cabinetry, your wastebasket, all these things are coming from oil. So you might not think that you use that much oil, but you really do. And that's because we take that crude oil and we separate out all those hydrocarbons and we can create all these different things from them. We're really, really good at creating cool stuff out of oil. Now this is a rather fuzzy picture. Sorry about that. I blew it up quite a bit and it wasn't real high pixel quality. But this is a picture of the oil and gas fields. And you saw something similar that looked really similar when we looked at the coal fields. That's because oil, coal, gas, they oftentimes all occur right near each other. But you'll notice how much of it is just offshore. Okay, you've got some down in off Florida, off Texas, in the Gulf there. You've also got some off the coast of California. We do have oil mines, or excuse me, oil wells just off our California coast, some off Washington, Northern California there, and then a lot of it off of Alaska, you'll see up there, up on the upper left, and then some over off the East Coast as well. Now, as I mentioned earlier, we have to drill wells to get oil out. And so one of the big issues is all the environmental impacts that go into drilling an oil well. And one of the biggest controversial things going on right now is looking for new sources of oil. And one that's been in the news over several years now has been something called ANWR, and that's the Arctic National Wildlife Refuge found up in Alaska. So you'll see a map here. ANWR includes kind of all that yellow plus the little green area there. So the map off to the right kind of shows you. And Alaska is a very big state. It's very wide ranging. And so to give you an idea of size of how big this National Wildlife Refuge is, it's almost the size of South Carolina. So, decent in size. What they want to do is they currently have oil fields up in this area, but you see that little reddish pinkish square up there? That is a proposed development area that they want to go in and they want to drill for oil. There are geologists who have done studies and they say that there's oil in there. And depending on who's in the presidency at the time, when it was Bush, there was a big push to get oil drilled out of there. Now that Obama's in office, he's not so into getting the oil out of there. The issue is that this wildlife refuge is a primary area for caribou. They use this area, they live in there, they live in that yellow area. If we go back to the map here, they kind of hang out in this yellow area, but during calving season, they move out to the coastal plain, that little green area that you see on the map there. And the reason that they do that, they move out there to have their calves, is that if you haven't been to Alaska, you don't know, but they have pretty monstrous mosquitoes out there. I mean, these guys are major bloodsuckers. They can do some pretty good damage. And little caribou calves are pretty tiny, and so if they get swarmed with mosquitoes, they can pretty quickly take a lot of blood from them. They can become anemic, and they can also pick up West Nile and get really sick. Well, the caribou instinctively know that if they migrate out to the coast for their calving season, those nice marine winds blowing off of the ocean really help reduce the mosquito population. So they go out there to have their babies. Well, the problem is that they're a rather sensitive species. They don't do really well with development or having any pipelines. They've done studies where they notice that if there's a pipeline, sometimes herds of caribou won't go under. Even if they've elevated the pipeline, they don't like to go underneath it, and so they'll try and change their migration route. Well, there's already a considerable amount of oil drilling taking place in this area. You can see the oil fields off to the left-hand side there. They're off to the west side. And then you see all the little spots where they kind of want to start drilling oil, and there already are some areas that are being drilled. So they want to go in and drill for oil. Now, the coastal plain is a relatively small area of the overall refuge. Okay, it's only about 5%. So you're looking at a pretty small area that the caribou use for calving, and then you want to go in and take over some of it and put in, and it's not going to be a small project. You can have roads coming through, and these big wells going in, a lot of noise, people traffic that they aren't really used to. So you're definitely going to have an impact on the wildlife. Now, for any wildlife refuge, there's something called a CCP, which is a Comprehensive Conservation Plan. And they are required to write up these plans that are basically like, what are your plans? What do you plan to do for the next, 15 years? So every 15 years, they have to update these CCPs for all the wildlife refuges. And they recently just updated the CCP for ANWR. And what the refuge and by the way, U.S. Fish and Wildlife Service, that is the government agency in charge of maintaining and controlling the national wildlife refuges. So what they wrote up in their report is that they wanted to take the ANWR coastal plain and change its designation to a wilderness area. And when you call something a wilderness area, when it's designated as that, that means that you can't have any development whatsoever in the area. No roads, no bathrooms, no pipelines, no oil drilling, nothing. It's strictly for wildlife. You can hike in, you can observe, you can do research, but it's basically leave no trace. So you go out, you do your thing and you come back. You can't leave anything lying behind. So if they're able to push that through, that means that would just stop drilling completely dead in their tracks. Now that's the plan. It hasn't been approved. It hasn't happened. This is all government, so it has to go through an approval process. Now, another thing fighting against them is that Alaska is up toward the North Pole. And as we learned in climate change, we see climate change impacts happening much more quickly in the polar regions than we do more in the center of the Earth. And so you're seeing a much greater rise in average temperatures going on, which is why we see all this melting of our ice caps, which is why we have polar bears dying off because there isn't ice for them to hang out on. They're actually drowning from swimming so far. So you already have that fighting against the caribou. You've got this increased climate change impact going on with them. And then you want to try and put drilling on top of that. So something that we have to consider. It still remains undecided if they're going to open drilling or not. As far as I know, they still have chosen not to, but at any point that could be turned over. You don't know. So if you find any links, send them to me. I just haven't had a chance to get online and look. So the question with this drilling in ANWR basically becomes a question of, is it worth it? Is it really worth it? Geologists go in, they drill rock cores, and they conduct all these ground air seismic surveys. They can map all the rock formations. And so they've gone through there and they have an estimate. And you'll see how wide ranging this estimate is. The estimates for the amount of oil held in these ANWR deposits is anywhere from 11.6 to 31.5 billion barrels of oil. Now, that's a huge, huge range. So let's look at the average number. So on average, say about 21 billion barrels of oil. Okay, well, about how much is that? Well, it's about enough for about 33 months at our current consumption rate of oil. So it would last us about 3 years. But you have to keep in mind that you can't get every single drop of oil out of those deposits, because once all that initial pressure comes out and then you put the steam in and pull some more oil out, you can only extract about half of that. So if you say, maybe you'll get an average of about 7.5 billion barrels of oil out, which are technically recoverable because you have to outweigh the energy costs of actually extracting that oil versus, whether it's really worth it. You really end up with only about a year's worth of oil. So really it comes down to, is it worth disturbing all these natural processes that are going on in caribou and their migration processes, not to mention all the birds and the other things, the systems that we don't even know about, to extract a year's worth of oil from there. Most people would probably say no. But you make that choice, and that's one of the reasons, another reason, why I want to reiterate, get out and vote, let your voice be heard. This is the only way that you can have your voice be heard, is to get out and vote and talk to your local representatives. Now, of course, along with oil, you have the issues, especially with offshore drilling, of oil spills. Okay, a lot of our oil gets transported in ships. It's a really easy way for us to transport it across the world. We get a lot of oil from the Middle East, and the only way to get it over here is by ship. We don't fly it on a plane, it's way too heavy and dense. So you definitely have issues with oil spills, and as most of you hopefully know, we just recently in 2010 had a major oil spill where we had an offshore oil drilling rig basically blow and have a leak, and we had oil pouring out into the ocean for weeks, and they still don't even know the total extent of damage done. It took them a long time to stop the oil from flowing out. So these are some of the issues that you have. The oil gets in the water, it coats the wildlife, they can't swim, they eat it, it does major damage. And there are actually probably big pockets of oil sitting on the bottom of these really deep trenches in the ocean that we haven't even found yet, and they're killing off all the life that we might not even know exists down there. So there's definitely some drawbacks to harvesting oil. Now, you'll probably hear in the news a lot lately that, we've become much more sustainable in that we're using domestic sources. The majority, you might pull up to a gas station, it might say, hey, the gas that you're buying here was all domestically supplied. It's all from the United States. Well, if you ever wonder where exactly that oil is coming from, it comes from a source called tar sands. And so I want to talk really quickly about what tar sands are. They're basically another source of oil, and they're primarily found up in Canada. And what they are is these sandy deposits that have a lot of this really sticky, gooey oil called bitumen in it. And they have anywhere from 1 to 20% of bitumen in it. And the way that we go about collecting it is very damaging to the environment. Now, bitumen is this really thick form of petroleum that's really rich in carbon, but it's poor in hydrogen. Canada, again, has a lot of tar sand deposits in its boreal forest. Think back to your biomes, a boreal forest, you're getting those coniferous, those evergreen trees, cold, harsh winters, so they have a lot of needles, so they're not being disturbed. They do get some snow, but these nice, dark, big, old forests up there, and the soils in there have a lot of oil in them. Now, the way that we go extracting that tar sand oil is, as I said, very damaging. What you basically do is you go into the surface of the forest and you take these giant earth movers and you just scrape off the entire top of the forest. You chop down all the trees, take out all the vegetation, scrape it all off. And a lot of times they burn it or they chip it all up and put it, in a compost facility or something. But you're talking about massive amounts. Once you scraped away all the vegetation, that top layer, then you have a couple tons of peat and topsoil to scrape away, because what you have to do, the tar sands are kind of below that. So then you have to scrape away all this other stuff. Now, meanwhile, of course, you're running these giant earth movers, which are using up all this oil as it is to get down to oil that you're trying to harvest. So it makes one kind of wonder where the scale is there. So now you're down to the tar sands. Now the big earth movers start scraping up these tar sands. What they have to do, and here's the note I said about using those big earth movers and all that. They take those tar sands and they have to take them over to a facility that basically heats them up. You have to heat it up so that you can separate the oil out from the sand. And what do they use to heat it up? Natural gas. So we're using a fossil fuel to extract a fossil fuel. Again, makes you wonder. They're taking natural gas, they're heating up this, they're separating the oil from the gooey sand stuff, and then they take the oil off and then they ship it out somewhere else. Now, they have to keep their equipment all cool and all that, so meanwhile, they're usually setting up near a local river and they're using that local water in the cooling process, and so you have risk of contaminating that local water supply. So the bitumen gets collected and then it gets sent down to a refinery where it is then distilled and used in different ways. The leftover sand, which still contains quite a bit of oil because they can't get all the oil out just by heating it, what they do with that nasty stuff is they go and they toss it in these giant sludge ponds and it just basically sits there. The problem with these sludge ponds is that from a bird's eye view, they have a real tight reflection on them. They kind of look very similar to water. And so you get these birds flying over that look down and they see a reflection, which they take to be water, and they swoop down to land in these sludge ponds and they get totally coated in oil and they die. So we're having a lot of wildlife deaths as a result of all these giant sludge ponds. Now, to give you an idea what they look like, this picture here is a picture of one of these giant sludge ponds, and that black little shape sort of, off to the left hand of the center there, that's actually a giant earth-moving bulldozer. So that's how big that pond is. It's just this huge, huge area, and you can see how reflective it is, how easily it would get mistaken. Now, here's some statistics for you to think about. For every 2 tons of tar sand, you only get 1 barrel of oil. 2 tons of sand for about 42, 44 gallons of oil. Not real good odds. You also, one of the pros to it and what a lot of people fight for is that you get a boost to your economic activity because you got create a lot of jobs. The local economy is benefiting because you got people coming to the area for driving the trucks and doing all of this. They're going to be eating at the restaurants, buying foods at the grocery stores. The housing market goes up. So it does really benefit that local economy. But you have a severe impact to the environment. So you have to think about all the ecosystem services, the environmental biodiversity that you are disrupting and impacting. Now, here's some pictures of the earth movers that are taking out those tar sands and moving them out to areas. Again, as far as oil goes, Canada is actually currently the largest oil supplier to the United States, and that is through those tar sands. Very disruptive process. By the way, Mexico is the number 2 U.S. supplier of oil. A lot of offshore drilling there. And Saudi Arabia and Iraq are number 3 and 4. So that's where the first 4 sources of our local, our oil that we burn in the United States comes from. Now, this picture here is a picture of a result of tar sand extraction. You see a nice boreal forest over on the right-hand side of the road, and off to the left-hand side, it used to look like the other side, and they've gone and scraped away just so they can get all those tar sands out of there. Of course, there's not anywhere close to putting back that forest the way it was. You've got exposed soil, you've got all kinds of things going on. So again, you kind of have to question, is it worth it or not? Maybe it's time that we got serious about switching to some alternative fuel sources. Some more pictures for you here, some sludge ponds from the tar sand extraction. You see a bird covered in the sludge, a little duck down there. It looks like maybe an eider who got trapped and is probably, unless somebody rescues it, he's not going to make it out of there. And it's honestly, it's just really ugly. You're losing that nice aesthetic value to the land. You're losing all those ecosystem services. You're destroying all the beneficial bacteria, the decomposition. I have a feeling in the next 20, 30, 40 years, we're going to start seeing a lot of this impacting us in a very negative way. So was having all this domestic oil really worth it? You have to question it. Okay, so in our next video, we'll talk about natural gas, where it comes from, how we use it, and then we'll move on to nuclear, and then we'll finish up.